Okay. Right, so it's not too difficult what we're looking at here. It's mostly just a bit of notation which you're familiar with. Before I continue, I'm correcting your maths exams at the moment, so I should be finished next week, I hope, sometime next week.
When?
Friday.
That's literally next week.
Come on, but you knew that before you asked, really, deep down. Anyways, I was disappointed with some people, to be honest. So far I've counted up at least, I think, 4 people who got less than 40. And this is a problem. This is a problem. So if you did not get the grade that you were hoping for, then that's something you really need to think about what you're going to do. Because the fact is, I've been doing this 10 years and I've never seen a student badly fail semester 1 and then go on to pass. That has happened exactly 0 times. So if you find yourself in this situation, then you are going to need to have a serious talk with your tutor about what your study plans are, because maths is not working for you. And of course, some people did well and some people did average. But the problem is the final exam contains half of the semester. The final exam, half of it is semester 1. So if you screwed up the semester 1 exam, I can't see how you could do well in the semester 2 exam if half of it is semester 1, you know. So I'm telling you this now before I give you the result, because it means when you get the result and if you're not happy with it, there's a huge responsibility of action on your part. You're going to need to do something, come up with some plan, because whatever plan you have is not working. That's fine, and then some of you, it doesn't really matter because you did badly because you're not working hard and you don't care too much about your studies. But that's okay, that's your personality type. Again, you need to come up with some plan about what you're going to do. It's real life. Different people have different personalities. Some people will work hard to achieve their goals and some people won't. So, you can either look at your results honestly and say, I got this because I screwed up and I need to change. Or you can look at it and say, well, life is difficult. These are your 2 choices, really. That's just the hard truth. Okay? So just keep that in mind before you get the result.
Why are you looking at me?
What? No, I'm spreading my gaze throughout the classroom, don't worry.
How do we get the results?
I'll give them to you in class. I personally, like I'll put them with your student number and maybe put them on the wall or something. Something like this.
How many have you corrected so far?
Well, I've split the corrections with Joan, so that's why I can only comment on the ones I've corrected.
We already have 4 papers less than 40.
It's with the business students, yeah?
And the engineers. Yeah. We took all the maths and split them in half. Well, just from a probability point of view, you know, if I have half the papers and 4 of them failed, then it's likely in Joan's pile. Yeah. It's not like we said we'll give the bad half to Stephen and the good half to Joan. You know, on average it should be 4 as well.
The rest of us.
Did
you correct any impressive papers? Yes.
The most impressive one was a 94 or 96, somewhere kind of in the mid-90s.
Engineer.
It was an engineer, correct, yes. But I'm not finished correcting yet.
What's the most impressive outside?
I don't know, I haven't looked at who's in each group. I'm correcting them all together, because it was the same exam. Okay, Venn diagrams now. Huh? It's unfair? What's unfair?
Like the same exam as the engineer.
Why is that unfair?
We're studying medicine. We're studying.
Yeah, but, you know, that's life. And like I said, to achieve your goal, you have to work hard. Yeah, correct. It's true. It's true. Do you think I want to be here teaching you? But this is the way life goes sometimes, you know? It is just not fair. Okay, Venn diagrams. So this is a topic which some of you have, well, probably all of you have studied before. It's basically to do with sets. So to get things started with, we need to define exactly what a set is. So a set is just a collection of elements. And the other thing about sets is that it's unordered, meaning you don't actually care about the order of your list. And the way we represent a set is like this, with these curly brackets. So here's a simple set. It contains the three letters A, B, and C. And the point I'm trying to make here is we only care about what's in the set and what's not in the set. So we consider that the same as saying C, B, A, or even the same as C, C, A, B. The reason that these are all the same is because what's in the set is the same for each of them. So if I said, is A in this set? You would say, yes. Is it in this one? Yes. Is it in this one? Yes. Is B in this one? Yeah. And is C in it? Yeah. The only thing that matters about a set is if something is in it or not. And the way we represent that is with this symbol. So this means element or belongs. So for example, I could say X belongs to this set X, Y, Z as an example. And then here I would say A does not belong to the set X, Y, Z. So far we just have two symbols. This is what we use to represent a set, these curly brackets. And then this here means is an element of the set. It belongs to the set. And then this one here is not an element of the set. We've seen sets a little bit already. So you might remember that we have this set, N, is the natural numbers. Or this set here, what was that one? Integers and reals, and this last one? Rationals, yeah. Okay, so a little bit now more to do with sets, but this is just a basic idea of the set. It's just literally a collection of things, and they're either in the set or they're not in the set. Nothing more to it than that. So we have to look at a little bit of notation now. Okay? Can I scroll down? I think everybody's seen this before in high school, middle school, right? I don't think this is new for anyone. But maybe the next part, there might be some new stuff in it. Okay, so how can we represent sets? So the way we represent sets, just like this, just with a circle. And the elements that are in the set, we write them inside the circle. So if this is representing set A, and set A is equal to, let's say, A, B, C, D, then we just simply write A, B, C, D inside the circle. Simple as that. Things which don't belong to this set, we write outside the circle, like E, F, G, etc., etc., etc. But there's a small problem, because you might say, well, there's many things that are not in this set. Like the number 2 is not in this set. Or, you know, the color blue is not in this set. So for sets, we usually have this idea of what we call a universe. The universal set, U. And this represents all the things in the universe we're talking about. So given the context here, what is the universe here? what are all the possible elements in this universe? Letters of the alphabet, probably. So we have the letters A, B, C, D in the set. So then everything outside, which is in this universe, is all the letters all the way up to Z. So usually the context can tell us what the universe is. So if we're talking about real numbers, what is the universe here? What is the universal set? It's all the real numbers. Yeah, sorry, that's what I meant. So if we're talking about numbers, the universal set is all the real numbers. If we're listing people who are in maths class, then people who are absent today will be outside it. So what would be the universe here? It'd be the attendance registered, the list of everybody possible. Okay, so the context can tell you what the universe should be. Okay, so what's also possible is we can compare two sets which look similar but aren't exactly the same. And again, you've probably seen this in school. Let's say this is set A and then this is set B. And we overlap them like this in our diagram because it's possible that there are some letters in A and also in B. So for example, let's say A is the numbers 0, 1, 2, 3. And let's say B, that's the numbers 2, 3, 4, 5. And let's say the universe are the numbers from 0 up to 9. So we're looking at single digit numbers here. Let's draw this to get us started. So my advice is it's always easiest to look at what's in common. So which elements are in both A and B at the same time? 2 and 3. But A also contains 0 and 1. And B also contains 4 and 5. But this does not include every number. There's 4 numbers which aren't in A and B. So we draw them outside here. 6, 7, 8, and 9 outside in our universe here. So just a little bit of notation. This symbol here, I think most of you know it. What's this called? Yeah. It can be also say A and B, but the word for it is intersection of A and B. And that represents what's both in A and B. So in this case, that would be 2 and 3. And it's represented here as that. The other one which is of interest, which you probably also already know, is this. Union? Yeah, union B. That's not how you spell union. Is it? Go on, spell it. Are you sure?
Yeah.
It looks weird.
You're a native speaker.
Yeah, but I'm a bad native speaker. You know? Why do you think I'm a good native speaker? You've been listening to me for like 10 weeks now. Okay, so union. What's union here?
A or B.
Yeah, A or B. So another way of saying it's
0, 1, 2, 3, 4, 5.
all of A and B. So in this case, yeah, what would it be here? 0, 1, 2, 3, 4, and 5. And on the picture, it's this. So it's everything together, combined in, together. So it's, in this case, 0 to 5. Okay. Next one. Yeah.
How can we tell between the union and the universal?
Oh yeah, they look pretty similar. You can put little lines on the top here. Yeah. Okay. The next one we have to look at. There's different ways to write it. I prefer to write it like this with a little tick, but sometimes you can put a C. Does anyone know what that one's called? Yeah, not A. Not A. Yeah. What does that mean, so? No, not quite B, no. Not in A. Yeah.
U and B, right?
Yeah. this is not A, so that just means outside A. And what would that be here?
Universe exists.
Yeah. 4, 5, 6, 7, 8, 9. These are not in A. Right? They're not in A. So in other words, they're outside this A set. Okay. This one? Not B, of course, and we'll just write it down. In this case, it would be 0, 1. 6, 7, 8, 9? Okay. Let's zoom out again. Right, let's start looking at ones. Well, no, I'll show you one more. One more. A less B. Not quite that. Not quite that. Yeah. Yeah, so what would it be here? No. No, that's A. 0, 1. In other words, it's A with the B elements removed, yeah. So A has 0, 1, 2, 3 in it. If you cut off the B, then you're just left with 0 and 1. So that's A less B. Okay, let's have a look at...
A less B, is it the same thing as A, B with the right thing on top?
A...
B.
What? Union?
A union B.
A union B.
With the thing.
With this?
No, just on B.
Okay, like this?
Yeah.
No. What would this set equal? Who can tell me that? A union, not B.
A.
That'd be 0, 1, 2, 3, 6, 7, 8, 9. You see?
No,
What you meant...
No, 2 wouldn't be there.
Why wouldn't it be there?
Because it's not on B.
Hang on, you have A. What's in A?
0, 1, 2, 3.
Yeah, and then you add that with what's not in B. You see, I think what you meant to say is A intersection, not B. Yeah? So that's... What's A intersection, not B?
0, 1, 6, 7, 8.
0,
1.
1, 6, 7... No. Just 0, 1.
Yeah, it's the same thing as the other one.
It's the same thing as this.
Yeah.
Yeah. So you've already figured out a rule, so to speak, that A less B is equal to A intersection, not B. Now, we're not too worried about rules of sets like that right now. The most important thing is drawing the sets and figuring out each part of the set. The last thing, symbol I need to show you is this one here, called the cardinal or the size of A. Hashtag A, correct. Does anyone know this one? You could probably guess from its name even.
Everything.
It's just how many elements are in A. So in this case it's 4 in A. There's 4 elements in A. Yeah?
Can I just ask
Yeah.
A union B with the small thing on top?
A union B dash.
Yeah.
Yeah?
Is it the same thing as B, the small thing on top, union A?
B union A dash.
No, with the thing on A. On B, sorry.
Oh.
B.
A union B, is that the same as what?
B,
Yeah?
kind of thing.
Give me words, man. Union
Dash.
intersection.
Dash. That thing.
Dash, slash.
The
Dash.
Yeah, union
Yes, that's the same thing.
A. But you know, when you were doing it, you said A union B prime. You chose everything in A, even though it says like with not B, and there was a little bit of B. The middle has B in it.
What are you saying, man? Give me a question.
Can you scroll up? Let me show you.
Yeah,
Yeah. You see here?
this one.
Yeah.
Yeah,
Now that B prime means everything not in B, right?
correct.
And 2, 3 That is in B.
Correct.
So why are we choosing it?
Because it's in A.
So that's what I'm saying. But when you switch it the other way around, the first thing that comes is what is
Fine.
Yeah.
Fine. So B dash, what's in B dash? 0, 1, 6, 7, 8. Union, what's in A? 0, 1, 2, 3. So the 2 and 3 gets tagged on at the end. This is a good question, because I've used up a lot of energy now talking to him.
A intersection B is like both A and B, right?
Yeah, what they have in common.
But 0 and 1 is not.
A intersection B dash.
That doesn't make sense.
What's B dash? What's...
Not A.
Yeah, no. B dash is 0, 1, 6, 7, 8, 9, right? And what's A? 0, 1, 2, 3.
What's the intersection?
And what's the intersection? What letter is, what number?
2 and 3.
what?
No. 0 and 1. Only 0 and 1 are in both. Only 0 and 1 are in both. You can see it right there. 0, 1, 0, 1. This is A, this is B dash.
Oh.
Yes? Okay, no more questions now. Stephen tired. If you charge necessary. This wasn't supposed to be a difficult lesson. So, this lesson is practicing mostly the notation, the symbols, really. So, now that we're into semester 2, I have to leave it up to you to take responsibility on the amount of homework you do. Because you'll have many things to be doing in semester 2. You'll have to be studying for the final exams. You'll have to be doing coursework, etc., etc. So you must now take ownership of your homework, and you need to figure out how many of these you need to do and when you can do them. Okay? So you can get... Yeah, we'll just do these in class for a few minutes, and then you should do some of them at home. If you're having trouble with them, of course you should do more. There's a good few there, but a lot of them are quite short. Like, for example, the first question is just true, that should say true or false, not true or false. There's a couple of interesting true or false questions there in number 1. I think you should try and figure them out. Okay, can you try these? Let's see what the next... 10 minutes. 10 minutes maximum of these, okay? And then we'll go on to the next lesson.
Sir, what does I mean? It has 2 sets. What's that?
Which one?
The one I.
One I.
Yeah, the last one. Why does it have 2 sets? What does
One
that mean?
one L.
Yeah, KL, sorry.
Yeah, I know, that's a juicy one. You have to think about that. I'd ruin it for you if I tell you straight away. I want you to think about it. Yeah, because you weren't in class. So you'll need to share and collect one at the end of the class. Oh, I'll just get it now. I could do it in a couple of minutes if not looking at you guys. So how many people need a workbook and miss it? 1, put your hand up, 2, 3. Okay, I'll be back with 3 books, no more, no less.
set. When and
Set,
set.
set,
Yeah.
okay,
Yeah.
okay.
You have you need the course book as well, right?
And who else needed one? Amjad.
I mean, it's true, sorry. Because one or two
Yeah.
are
Oh, sorry. I forgot to say that symbol. Guys, I forgot to show you this symbol. I think some of you know it. What's this symbol? Yeah. It's the set with nothing in it. So there's nothing in this set. So every statement is always like this. No matter what you pick, there's nothing in the null set. It's an empty set. Yeah. Yeah. Ah, flip. I forgot that symbol too. Well, it's a different, Sabrina, it's a different symbol. This symbol here. Subset. Subset. So, for example, you could say XY is a subset of XYZ. So what you're saying is this set, XY, is inside this bigger set, XYZ. Everything here is also in this one. That's true, yeah. Yeah, what's the difference between this and this?
No.
Thank you, Captain Obvious. What's the meaning difference? Yes. Does anyone know? Oh. So, if you use this symbol, you're saying it's possible that the smaller set could equal the bigger set. So, like here, X, Y, Z is a subset or possibly equal to X, Y, Z. So in this case, it's obviously, it's actually equal. It's the same set. It's kind of a little bit like this and this. A little bit. Yeah? 2A.
So it's bracket with one and one, but it equals bracket.
Yeah, what do we think, guys? 2A. Is that true or false?
It's true, but what is the equal?
It's true.
Oh, you're saying those two are the same set. The set with the number 1111, is that the same as the set with the number 1 in it?
Yes.
Yeah. And the reason is, both sets have only 1 in it. It doesn't matter that you repeat it.
And B would be true.
What about 2B? True or false?
True.
That's true. Good, yeah. 1302. Yeah, yeah. Again, the point I'm making is the order is not important. What about 2C? True, good. D? D? True.
Then false. It's not equal.
Yeah, no, I didn't.
It's impossible.
I said
It's or equal.
yeah, it's a subset or equal. So in this case, it's a subset. Yeah. E? No, he's false.
Oh, there's no equal.
There's no. Yeah, good. No equals. F? True. True. G?
False.
G is true.
True, yes. Because that's 0.
No?
So it's everything.
The null set can always fit inside anything. H? Good. And I?
False.
False. Good. 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 Yeah.
You know, you said the null set can always fit inside anything.
Yeah.
Can the null set be a member?
Yeah.
Like, you know, instead of the C sign? The
No,
sign?
no. It can always be a subset,
Okay, but it can be a member.
but not necessarily a member. Yeah. Question?
Oh, it's a subset.
check. 1L, is it?
Yeah.
I think that answer might be wrong.
Yeah.
1L.
Yeah. Should be easy.
Does it change anything the fact that we have two characters?
Oh no, sorry, it's correct. The answer is false, and it is false. It does change it.
What does it change?
So when the elements are concerned, you're counting out the first set as an empty set, so it has everything.
Are we talking about this one?
Yeah.
This one is false because it should actually be the set that contains only the number 1 does belong to the set which contains the set that contains 1. Now look, if this is confusing, you can actually see it quite easily. If you say let the set that contains 1 be the letter A, then is it true to say A belongs to the set that contains A? Yeah. So by simply making this substitution, it becomes clearer. So this is false then, to say it's not belonging to. Yeah.
So if there is a multiple equation, should we read it through left to right?
For the sets?
So especially for the 8L.
8L. Ah, no, you should do the brackets first.
Except apart from the brackets, if I solve the bracket, should I open?
Left to right would be usual. What did I leave? My coffee. Oh, thank goodness. I thought I'd lost it.
What was this last?
Less. Remove.
Oh.
Question? 3 and 4. Let's have a look at 3. A, B, C, D. A, B, C, D. B is C, E. Everything is A to F.
So F was your
Yeah, and the only thing that they share in common is C. Looks good to me. And then this one here, 4, you have A is 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, it goes up to 9, doesn't it? B is 2, 3, 5, 7, 10, and 2, 3, 5, 7, 10, and they don't share 10. And the universe, so the only thing that's not in here is 0. Yeah, that looks fine to me, yeah.
Steven,
Yes.
what does it mean, like, remove, not S?
No, same thing. Like when I say A less B, you know, that means A remove the B.
No, but remove not the B.
Oh, no, not this again.
U slash S dash
U slash
S
S
dash.
dash. Yeah. That means you take the set
It's
U
like remove nothing.
and you remove the things which are not in S.
So the opposite.
Do you know what's in S?
S is
Not an
Stephen.
S?
Yeah, Stephen.
Okay. Do you
S
know
is Stephen.
do you know what's not in S?
Yeah, it's A, E, I, O, U.
Do you know what's in U?
All the alphabet.
Yeah. So take U and delete what's in not S. So that'll be many letters, won't it? Because it'll be the alphabet. Or no, you said S is the letters in my name.
Yeah.
So not S is many letters like A, B, and so on. You take them out of U. Yeah. Amjad, it might be easier for you if you list everything in U, list everything not in S, and then delete. Yeah. Yes. Which one? 1G. Yeah, the null set is not in that set 1. You know, what elements are in this set? Yeah. Is the null set in this set? No. Only 1 is in it. Only 1 is in this set.
Sorry.
Yeah.
Is one prime number?
Say again?
Is
No.
one prime number.
Oh wait, so you remove not an S, so it's S.
Yeah, it's just S. Steve. Yeah.
Mind blown. Okay, guys, we'll continue now in a minute. Although, is that Tiago outside there?
Yeah.
Yeah.
Yeah. Do you need me? Okay. What was I saying? Oh yeah, so in a moment we'll continue. But oh, Tiago's confusing me. What does he want?
He's distracting me.
Hey Tiago, do you need to talk to the students? Yeah, well, no, but I'm going to start the second lesson, so now would be a good time for an announcement to them. Yeah. Right, so before we go on to the next lesson, then Tiago just has something to say.
Hi guys, just a couple of updates in 2 points. One, we will have a medical tutorial on Thursday. I've just sent an email to you guys saying that it was just for UCLan students, but actually the